All right, let's talk about the properties of isosceles triangles. Now, first thing, of course, an isosceles triangle is a basic triangle, but with two sides the same length, which means that the angles at the bases of those two lines will also be the same size. So these two sides are equal, indicated by the lines drawn on the sides there, and these two angles must therefore also be equal. Therefore, x is the same as 32. Now, you often see these in a number of different situations. One of those, of course, is between parallel lines, because you've got obviously one line can be form part of the base, and these two can be what we call transversals. So I'll talk about those in a moment. The other one, of course, is inside circles, and circle, of course, see these good angles quite a lot, because when you've got two things the same, quite often those are radii. They're the angles protruding from the center all the way to the circumference, and we'll talk about how they play out shortly. First of all, calculating these. Well, first of all, of course, if we know this is 32, this one here must be 32. And of course, we know that the angles, some of the angles in a triangle are of course 180. So what we're going to do here is we can say, well, x is 32. So start off by saying x is 32, because obviously, and the reason, of course, is base angles of isosceles triangle are equal. I tend to write it differently. I tend to say base angles isosceles triangle equal. And that's what I tend to write. Now, of course, y is going to be the sum of the angles of a triangle. So y is going to equal 180 minus the other two. And the other two, of course, is going to be two lots of 32. Two lots of 32, of course, is going to be 64. And of course, 180 minus the 64 is going to give us 116. And there's going to be our value of the apex in this case. Now, let's have a look. It says this one here, this time we're given the top of the triangle. We can call it the apex, if you like. The apex of the triangle given 28. I've just put a little scribble over that. Let's see if I can find something to rub that out with. Here we go. Fantastic. All right, we've got 28. So now we can easily find the other ones, because we know that these two, because they're equal, I can say x is equal to 180 minus the 28. And of course, they've got to be the same. So they're going to be divided by 2. So I can put the whole lot over 2. Now you notice it did it slightly differently here. They said x plus 28 is 180, or 2x is 100 minus 28. Or I could just do 180 minus 28 divided by 2, and that gets me to the same place. So let's have a look. 180 minus 28, all divided by 2, and that gives us 76 degrees. So lots of ways of doing that. And of course, the reason here is going to be base angles isosceles triangle equal. Now, one thing I don't like, what have they done here? Yeah, just so you know, they've got a little hyphen in there. That would indicate this is a possessive noun. Angles can be plural, but not possessive. So you're really shouldn't write angles like that with an apostrophe. Not a great thing to do. Much better to write angle and just put an S there, and that would be correct. All right, hopefully that makes sense. Now, where do we see these? Well, we talked about in circle geometry, for example. Here we go. One of my favorites, circle geometry. Ugh. Oh, that's a terrible circle. Okay, let's just make it slightly less terrible, but only slightly. All right, if this is the center of the circle, suddenly we've got a triangle here. I'll just draw a triangle here of some sort. Here is my triangle. Now, of course, because this is equal in length to this, because these are equal, these are radii, then we can use the term. We can say, let's say, for example, let's say we're saying, well, this is 30, for example, and we're saying x is here, we could say that x is equal to 30 degrees. And the reason we're going to put is base angles isos triangle equal, and then I would go radii, which is the spelling, equal. And I would tend to write it like that. Some people don't. They leave the equals out here and they just put it here. Over to you, but that would be the reason I would give. Also, you often see because triangles, of course, have straight lines, which is very useful, you might have, say, a couple of parallel lines. And in between those parallel lines, they might go ahead and draw themselves some kind of triangle. And they might say, let's give this some angles here. So let's say, for example, they say, if this angle is, let's say they make this 60, for example. They say, that angle is 60. And they say, let's find some of the other angles in the triangle. So, for example, they might say, what would this angle, let's say these are equal, just for example, yeah? And they might say, find angle A, B, C, and D. Well, of course, this is nice and straightforward because we know that these two angles here are what we call alternate angles. So B is 60 degrees, and we could say alternate angles equal, comma, parallel lines. Of course, we know that A is equal to the supplement of 60. So A is equal to 120 degrees, or 180 minus 60. And we know that these are co-interior. And co-interior, by the way, should have a hyphen. So we've got co-interior angles. I put supplementary, comma, parallel lines. That was very poorly written, by the way. And of course, we know that C must be the same as B. C is equal to 60 degrees. And now we can say base angles isos triangle equal. And of course, we know what D is. So D, and I'll put D is equal to, well, we know that these two, B and C, together are 120. These are 60 and 60. So D must also be 60. So now we have a really interesting situation. D is equal to 60. And now we can say a different reason. D is equal to 60. And if we can put equal triangle angles equal. In other words, this is now an equilateral triangle. So this side here, from here to here, this must also be equal. Of course, these are also parallel. But again, look at this and think through how the triangle geometry works. So we thought it was a base isos triangle, but suddenly we realized, of course, that this line here was in fact the same length as these ones here. And it wasn't just an isos triangle, it was an equilateral triangle where all the angles are equal. Okay, hopefully that makes sense. All right.